From first thing in the morning till last thing at night, we all rely on electricity.
Hey, I was watching that.
All this electricity is available day and night at the flick of a switch. So how is it generated?
To generate electricity, you need three things: a magnet, a coil of wire, and movement. Turn the magnet and the needle rises, and you're producing electricity.
The movement of a magnet near a coil of wire generates an electric current. This simple action is all you need. Keep the magnet moving and you'll have a constant supply of electricity.
Here at Drax Power Station, they generate a huge amount of electricity. They use big coils of wire and massive magnets.
This is a generator. Inside is a magnet which is as long as a bus, and it's spinning 3,000 times every minute.
And surrounding the magnet are hundreds of coils of wire. To move the magnets, power stations like this start by burning a fuel to heat up water. It's heated inside metal boilers and pipes, so you can't see it. But as the water gets hot, it turns into steam, just like the steam from a kettle. When it pushes against the blades of a turbine, the turbine spins. The same sort of thing is happening inside the generator. As the turbine spins, the magnet spins inside a coil of wire, generating electricity. At Drax, they heat up thousands of litres of water every day, which means they need plenty of fuel.
They burn coal to heat the water. In fact, it's the biggest coal-fired power station in Western Europe.
The coal is brought by train from a nearby pit. By burning about 40 trainloads a day, they produce enough electricity to meet the daily needs of around 4 million people. Drax is one of many power stations in the UK, and most burn fossil fuels. About 32% of our electricity comes from burning coal. Another 32% from burning gas. And just 2% from oil. That's 2/3 of our electricity generated from fossil fuels. The problem is that even though there's enough of these fuels to last for the next 100 years or so, they're damaging to the environment. Burning fossil fuels releases carbon dioxide gas into the atmosphere. This adds to the greenhouse effect and is thought to be changing our climate. Burning coal also releases sulfur and nitrogen into the atmosphere, causing acid rain. One alternative is to use nuclear fuel like uranium. It already provides us with 30% of our electricity. Nuclear power stations produce hardly any acidic gases and emit virtually no carbon dioxide. But they still pose problems for the environment. The fuel is radioactive, and there are real worries about how to dispose of the dangerous waste that's produced.
Another problem with coal, oil, gas and nuclear fuels is that we've only got a limited resource. So eventually we're going to run out.
We need to look for alternatives. At the moment, the remaining slice of electricity, just 4% of the total, is generated by using less harmful energy sources. So what are they?
Here's one for you. What is 50 metres high, weighs 50 tonnes and can provide enough electricity for up to 1,000 homes, and doesn't burn a single thing? A wind turbine. And imagine what you could do with loads of them like this. And I think they look really cool.
Wind has been used as a source of energy for 4,000 years. High-tech and graceful turbines like these can now be found on hilltops dotting the countryside. As the wind blows, it pushes against the blades and they swing into action. Just like the other power stations, this turning motion moves magnets inside coils of wire at the top of the mast. There are several other ways of generating electricity that don't require burning fuels. Hydroelectricity is generated when the energy of falling water is harnessed to make turbines spin. Oceans also represent a huge untapped source of clean and renewable energy. The idea is to use the movement of waves or the tides to drive turbines. But electricity can also be generated without depending on any movement at all. Solar power has loads of potential. Just think about all that unused roof space. But the technology is expensive, so it's still rarely used. And here in the UK, there isn't much chance of being able to rely only on solar power, because there simply wouldn't be enough light in the middle of winter.